and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Will Sweet.
Thank you, William, and thank you everyone else for joining what will be a short talk today about the difference between splitting chemistries and emulsion chemistries. I'm also going to be referring to these splitting chemistries as non-emulsifiers. That's just kind of how I talk about them, but it's synonymous with splitting. And how many ways are there to clean something? That's where we're going to start off this conversation. And these are looking at different mechanisms of cleaning. So different verbs, different ways that different chemical products are able to clean the soils that you're looking at removing. So there's wetting, there's solubilization, which is essentially emulsifying, another way to think about it, displacement, deflocculation, etc. And emulsion, what exactly are those? And again, emulsion, that is when oil and water are joining together, basically solubilizing together. So an emulsion, you can see kind of a mock-up here in this figure. Emulsion cleaners tend to be these oil droplets that are suspended in water. So on a very microscopic level, it may look like the figure on the screen right now. But in practice, it looks like very oily water. It's when the oil is actually being mixed together with the water or the water-based cleaning product. So emulsions, what are they used for? I mean, solvent cleaning, these chemical cleaning applications, emulsions have been around for a very long time. However, there are soil loading limits because eventually there's going to be so much oil in there that there's more oil than soap. Is a very dumbed down way to think about it. They are good they can be good cleaners, especially when it comes to heavy soils and greases. So almost like a gross cleaning before a final polish or something like that. And surface protection is possible after the cleaning, so post-cleaning. And these are most often done in immersion, so not really sprayed. And that's because, again, you'll end up spraying oil after a little while. And then on the other side of the coin, the splitting cleaning agents, or the non-emulsifiers, there's multiple cleaning actions at work here. Speaking of the pH, it can actually be an alkaline product or an acidic product. You will see more alkaline than acidic, but it is possible to do it with either. These are water-based products, just like the emulsifiers. And the soil loading is actually positive because it's not going to mix in with the entire makeup of the bath. It's actually going to split, and most oils are going to rise to the top. This can be done in immersion or spray applications. With the oil splitting out of these products, you're not going to be spraying as much oil as you would with an emulsifier, especially we'll get to a little bit later if you're removing the oil that is split to the top of the bath. This can be available for all metal types, compatibility and rust protection wise. And like I was mentioning, splitting is going to extend the bath life, assuming that you're able to get the oil out of or off the top of the mixture. And splitting simplifies disposal. So you have less things that are mixed up whenever you have to get rid of a bath over time. You don't have to worry as much about everything that's being mixed in there because you're able to get most of those oils and different coolants out of there. This is a little mock-up of what the difference between these two types of actions look like. So oil splitting on the left, obviously, you see that thin oil layer on top. And on the right, there's the same amount of oil in that mixture. It just happened to solubilize and completely mix and emulsify within that sample. Then some of the negatives. So with these emulsions, they require very good rinsing because, again, there's oil in the mixture, especially over time and more usage. So you're going to have to rinse very well to make sure all the oil is off of the part. Slow drying, because again, the oil is in the mixture the whole time. Economics. So, I mean, you're going to have to throw away a lot more of your cleaning product because it's not going to last as long as a splitting chemistry would. And it's not always the final answer. As I mentioned earlier, it requires very good rinsing and is not always the best final polish for parts. Splitters, some of the negatives. Skimming is required or strongly encouraged. So again, you're splitting the oil to usually the top of the bath and then you need a skimmer or a coalescer or something like that to skim off that oil in order to get all of the benefits that you're looking for with these chemistries. Wide range of options, economic range, effectiveness range. Many different products do this depending on what chemical suppliers you're working with. So you can go for very extensive ones, very aggressive cleaners, very mild cleaners, what have you. There's a lot of options in this space. And then you can be very specific when it comes to process and metal specific products. Again, if you want to spray one of these products, which you're not going to be spraying many emulsifiers, but some of the non-emulsifiers, they're going to come with defoamers built in, so that if you're spraying, especially at high PSIs, the product is still not going to foam out of the machine. Non-emulsifier, before and after coalescer. These pictures are an example of a coalescer. You can see on the left, very oily substance. You can't really see the bottom, but that's all of the oil is on the top. That is just a bath mixture. And then over time, as the coalescer is able to split off all of the oil on top of the bath, it is much cleaner on the right. Then oil and water separators, aka coalescers, like the picture we just showed you. This is a little mock drawing, very simply showing what happens in this coalescer. So it's based off of time. That is a big proponent in these systems. So you bring in the oil and water mix coming in from the left, and over time the oil is going to continue to split and rise to the top, and it comes out on the left as well, and the water is going to go under the weir and come out all the way on the right back to the bath. There are many different kinds of oil separation systems. Coalescers are just a very well-known one, and you can see another drawing in the bottom right of this page for one of those. But there's also floating oil pickup. So it's going to float on top of the bath and then really pick up the oil on the top as it floats over the entire surface area of the bath. You can also pump to a separator. Typically they are in line and used in conjunction during a cleaning process, but you can pump somewhere else and then pump it back. And return gravity flow to wash. So that's kind of what I was referring to there. Most of these inline coalescers are removing oil from the top and returning it back to the bath at the same time. Each technology does have their place. So emulsions, very good for heavier grease and oil removal. Good when oil coating is desired after gross cleaning. So that can be used for corrosion protectant or something like that. That's the reason a lot of oils are used on parts anyways, to stop steel parts from corroding or rusting. But again, it's not always the answer to a final polish or the final clean of a product. So then moving on to the splitters, much longer bath life, because again, that oil is not going to be mixed in with the entire bath. You're able to remove from the top. You can operate cleaners due to oil removal. Cleaner bath equals cleaner parts. Here's something we like to say, KYZEN is you're only as clean as your final rinse. Lower cost of operation because you're not going to be throwing away as much chemistry as often, and leading into less fluid waste. So there's several cost savings there. Cleaner parts, and it's really it seems to be a better process over time. So oil splitting versus emulsifiers. For most people these days, splitters are the winner. It seems to make the most sense. But again, emulsifiers do still have their place, especially in gross cleaning. Some of the FAQs on this topic. You mentioned that splitters can be alkaline or acidic. Can emulsions also be alkaline or acidic? Short answer, yes, but most of them are in the alkaline space. So, I mean, there's various different types of emulsion cleaners, just like there's various different types of non-emulsifying cleaners. You're going to see more often than not alkaline, but it's possible to get some acidic cleaners there as well. Why can't I skim or remove the soils out of the emulsion cleaners? And that's because the same oil is going into either one, prefacing there. but the oil is not being split to the top. So these coalescers and these skimmers are still going to remove whatever is on the top of these baths. It just happens to be chemical as well as oil, since it's emulsified and mixed together. So it's still doing the same action, but it's actually taking out cleaning product as well, if you're using an emulsion cleaner. You mentioned that skimming takes out the oil from splitter materials. Does it take any important parts of that splitter cleaning agent out of the tank as well? And short answer again, no. The products we make and many of the other chemical suppliers out there, they are stable products, and you're not going to be able to take out any specific components. So it is only taking out the oil. If there's any product towards the top of that bath tube that it's reaching, it's taking out full product and not specific components by itself. And finally, that oil separator coalescer looked complicated. Are they easy to operate? They are actually much easier to operate than they seem. Again, essentially, time is the biggest mechanism here, because you want to give the bath enough time to fully separate the oil to the top. So you're allowing a coalescer, just allowing more distance for the bath to flow in order for the oil to separate from the top and then be removed. So again, time is pretty much the only thing that you're really worried about there. Other things, you can also lower the temperature. So the best time to run a coalescer is when all the shifts are over, and maybe you have a couple hours of downtime, so the entire bath can cool down and slow down, and then the oil will separate quicker. But that is really the only topics that you're really worried about when running a coalescer. And that is all I have for today. And I'll hand it back over to William.
Thanks, Will. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.